Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Student, in our last video we discussed the concepts of minors, cofactors and adjoints. And we studied how can we find the cofactors of a 2 cross 2 matrix and 3 cross 3 matrix, as well as how to find the adjoint of a 2 cross 2 and 3 cross 3 matrix. Now student, in this video we will study another important topic which is called inverse of a matrix. How can we find the inverse with the help of determinant concepts? Because inverse we already studied in matrix chapter, but there we applied a different method. Now here we will apply a different method. So first we will discuss inverse of a matrix. Inverse of a matrix. Okay student, first we will see what is the definition of an inverse, or what is the formula of an inverse of matrix. Student, if suppose A is a matrix, if suppose A is any square matrix, this is a square matrix, then its inverse is represented by a power minus 1, and it is defined as 1 divided by determinant A into adjoint A. Student, this is the definition or formula of inverse of any square matrix, that is 1 divided by determinant A into adjoint A. So student, here to find inverse, the very important thing is determinant A. If suppose here, if matrix A is a singular matrix, if suppose student, whatever the matrix, square matrix we have taken, if that square matrix is singular, what do you mean by singular? That is in bracket I write. Singular means determinant is 0. A matrix whose determinant is 0 is called as singular matrix. So student, if you are finding the inverse and the matrix is singular, means whose determinant is 0, then the matrix does not have any inverse. So it means student, to declare an inverse of a matrix, the very important thing is determinant A. If our determinant A is equals to 0 or a matrix is singular matrix, then that particular matrix doesn't have any inverse. Does not have any inverse. Inverse is possible to find if a matrix is non-singular. Non-singular matrix. Non-singular means determinant A is not equal to 0. It can be positive, it can be negative, anything, but it is not equal to 0. So student, this we should keep in our mind when we are finding inverse. And the next part is adjoint, and we know how to find adjoint. It is just a transpose of a cofactor matrix. Okay students, this is about the definition of inverse of matrix. Now let us go to the problems of inverse. How can we find the inverse of a matrix? Okay students, now let us take one 2 cross 2 matrix. If A equals 1 minus 1, 2, 3 is a matrix, find A inverse. Student, here A is a 2 cross 2 matrix whose elements are 1, minus 1, 2, 3. This is 3 here. He has given a matrix and is asking us to find A inverse, and it is represented as A power minus 1. So student, first we will write the formula. A power minus 1 is equals to 1 divided by determinant A into adjoint A. So first let us find the determinant first. Determinant A is equals to 1, minus 1, 2, 3. Okay. So student, here if I expand this with the help of RCM, I will get 3, 1 into 3, 3, minus 1 into 2, it's minus 2, minus into minus is plus 2. So finally it is 5, which is not equal to 0. Student, if you are finding inverse, then very important thing is determinant, because if the determinant is equals to 0, then it doesn't have any inverse. Inverse does not exist for a matrix whose determinant is 0. The reason is because determinant A is in a denominator, so we know that in mathematics or in any concept, if the denominator part is 0, whatever the numerator part is, we will declare the answer is not defined. So because of that reason, at any cost, our denominator cannot be 0. And in our inverse, the denominator part is determinant A. So this must be always not equal to 0. It can be positive or it can be negative. If it is equals to 0 here itself, then we will no need to find any adjoint. We will declare that inverse does not exist. So student, here I got 5 is not equal to 0. So let me find adjoint now. Adjoint of A. Student, in last video I told how to find a short direct adjoint if it is a 2 cross 2 matrix. I told the shortcut, so I will apply the same shortcut here. So that shortcut is without using any cofactors. So what I should do to find adjoint of 2 cross 2 matrix? I should interchange the principal diagonal elements. So 3 comes here, 1 comes here. Okay. After that, I should change the sign of the other 2 elements now. I should change the sign of the other 2 elements. So I have negative 1, so I will write positive 1. I have positive 2, I should write negative 2. So student, this is the direct adjoint of the given matrix. Now let me substitute in the formula. So formula is A inverse is equal to 1 divided by determinant A into adjoint A. So this is equals to 1 divided by 5 into adjoint A. 3, 1, minus 2, 1. So finally each and every element must get divided by 5 here. So I will get 3 divided by 5, 1 divided by 5, minus 2 divided by 5, 1 divided by 5. This is the final answer. Okay students, let us go to the next problem. Now this time we will take one 3 cross 3 matrix. If A equals 2, minus 1, 0, 1, 1, minus 2, 0, 2, 1. Find A inverse. Student, this time we are taking a 3 cross 3 matrix and we will try to find the inverse of this matrix. So So solution. Formula remains same. A power minus 1 is equals to 1 divided by determinant A into adjoint A. So as I said in the inverse, the very important thing is the denominator part, that is our determinant. Let me first try to find the determinant of the given matrix. Determinant A is equals to 2 minus 1 0 1 1 minus 2 0 2 1. So student, I will take the help of first row to find the determinant of this matrix. So that says plus 2 into, eliminate the first row and first column, then what do I get? 1 into 1 is 1 minus 2 into 2, it's minus 4, so minus into minus is plus 4, okay, and its hidden sign are plus minus plus, so I have minus 1 but its hidden sign is minus, so minus into minus it is plus 1. Now this time I should eliminate first row and first column. So what do I get? 1 into 1, 1 minus 0 into minus 2, it's minus 0, or minus into minus, you can write plus 0. Anyhow 0 doesn't have any sign, you can write minus 0 or plus 0, no issues. The next plus, student, here 0 I will come, I will get 0 here. So student, this 0 into anything, definitely if I expand with this 0, I can eliminate first row and first column, I will get 2 here, but finally that is multiplied by 0, so we can directly avoid, but here let me write 1 into 2, it's 2, minus 1 into 0, it's 0. So now finally 1 plus 4, it's 5, 5 into 2, it's 10. The next 1 plus 0 is 1, into 1 is 1, plus 0, finally it is 11, which is not equal to 0. So student, this is my determinant and it is 11. Now after determinant, let us try to find the cofactors of each and every element of the given matrix. Because it is a 3 cross 3 matrix, so we don't have any shortcut to find adjoint, so better we will use the concepts of cofactors. So cofactor of 2. The next is cofactor of minus 1, cofactor of 0, cofactor of 1, cofactor of again 1, and cofactor of minus 2, next cofactor of 0, and cofactor of plus 2, last is cofactor of 1. Student, I have taken all the elements for cofactor, so let me write a hidden signs of these 9 elements, and the hidden signs for these elements are plus, minus, plus, minus, plus, minus, plus, minus, plus. Student, if I will not write these hidden signs, then I will get minus. So I must multiply these hidden signs to the expansion of these elements. So student, in this case, the first 3 elements expansions are these only. Inside the bracket, whatever I wrote, same thing will come here. So without wasting a time, I will write directly 1 plus 4, that is equals to 5 into plus, it is plus 5. Next 1 plus 0,
So it is 1 plus 0 is 1 into minus 1. Next is 2 minus 0, it's plus 2. Now student, let us expand with the help of second row. So this time if I expand with this, then what do I get? Cofactor of 1, minus 1 into 1, it's minus 1, 0 into, 2 into 0 is 0, so minus 1 into minus, it's plus 1. Next cofactor of this element, so what do I get? This is present in second row and second column, so if I eliminate second row and second column, I will get 2 into 1, it's 2, minus 0 into 0, it's 0, so it is plus 2. Next, cofactor of minus 2. So for this I should eliminate third column and second row. 2 into 2, it is 4, minus 0 into 1, it's 0, so this is minus 4. Next, third row first element, that is 0. The cofactor of 0 is minus into minus plus, and 1 into 2 it is 2, minus 1 into 0 it is 0, so it is plus 2. Next, for this 2, we should eliminate last row second column, so 2 into minus 2, it's minus 4, minus 1 into 0, it is 0, so it is minus into minus plus 4. And next is last element, so I should eliminate last row and last column, so I'll get 2 into 1, it's 2, minus 1 into 1, it's minus into minus plus 1, finally it is plus 3.
Student, these are the cofactors of the given matrix. Now first, with the help of these cofactors, I should write adjoint matrix. That is very important now.
So student, adjoint matrix is adjoint of it.
As I said, the definition of adjoint is transpose of cofactor matrix. So what I will do, I will take this first 3 cofactors in first column in my adjoint matrix.
So first column is 5 minus 1, 2.
Directly I am writing adjoint matrix without writing cofactor. Because what happens, if I write cofactor matrix, then I should take transpose in the next step. That is my adjoint. So here I am wasting my time by writing cofactor matrix. So if I directly write like this, I can save my one step.
The next 3 cofactors I will write in second column. 1, 2, minus 4. Last 3 cofactors I will write in third column. 2, 4, 3. Student, this is the adjoint of the given matrix.
Now let me write the formula. Formula is already written here. Let me substitute in the formula.
So we will get so A inverse is equals to 1 divided by 11.
11 is the value of the determinant. So I written 1 divided by 11. Now adjoint.
What is adjoint? 5, 1, 2, minus 1, 2, 4, 2, minus 4, 3.
Now student, if you want, you can divide each and every element of this matrix by 11, because this matrix, that is adjoint matrix, is multiplied by or divided by 11.
multiplied by 1 by 11 or divided by just 11, or you can stop here.
I hope you people understood the concepts of inverse of matrix. Now students, let us move on to the next topic, which is also very important in determinants chapter, and the topic name is called consistent and inconsistent of the equations or matrix.
Consistent and inconsistent
of a matrix or equations. So student, here first let us see
the definitions of these things. First is consistent.
Consistent, in this case the definition of consistent is a matrix or equations which has solution, which has one or more solution, that is called as consistent. So student, the definition of consistent is, here in general we will take equations to discuss about this topic. To discuss about consistent and inconsistent, we will take simultaneous linear equations of 2 or 3 variables.
The system of equations are said to be consistent if it has solution.
If it has solutions,
In bracket I will write one or more.
at least we need one solution, or it has more solutions also. It can be 2 solutions, 3 solutions, or it can be infinite number of solutions. But if any system of equations which are giving solutions, then that particular equations are called as consistent. The next
some examples I'll take here. The equations are a1x plus b1y plus c1z is equals to d1, a2x plus b2y plus c2z is equals to d2, and a3x plus b3y plus c3z is equals to d3.
So this kind of 3 equations you will give if at all there are 3 variables. And how can we solve this equations to check whether it is consistent or not? Then these equations will convert it to matrix. These equations will convert it to matrix. 3 matrix. Okay. But before I go to the explanation of this topic, let me tell you what is the definition or meaning of inconsistent. But why I wrote these equations here? Because to explain you how the equations will be look like here. So the equations will look like this. The next definition is inconsistent. Now student, in consistent topic we discussed that a system of equations has solutions. Now in this case, in inconsistent, if the system of
equations does not have any solutions, then the equations are called as inconsistent. And obviously the equations look like this. Here d1, d2, d3 are the constants, a1, b1, c1, a2, b2, c2, a3, b3, c3 are the coefficients of x, y, z, as well as these are the real numbers, a1, b1, c1, and similarly a2, b2, c2, a3, b3, c3 are real numbers. Okay, students, since in this topic we are just taking the help of equations, so let me tell you there are two kinds of equations here. The first one is non-homogeneous equation and the second one is homogeneous equations. So student, first let me tell you what is about non-homogeneous equations. Homogeneous equations. So student, in any equation, if the constant part, that is towards our right hand side of the equation, if it is not equals to 0, then those equations are called as non-homogeneous equations. Example, a1x plus b1y plus c1z is equals to d1. The next, a2x plus b2y plus c2z is equals to d2, and a3x plus b3y plus c3z is equals to d3. Student, here I have taken three variables, so I must take three equations. If I am taking with two variables, that is simply x and y, then I should take only two equations, because it is a determinant and we know that determinant means a square matrix. Okay, so I have taken three variable means three equations. Student, these three equations are called as non-homogeneous equations. The reason here is the constants towards my right hand side are not equals to 0. It is d1, d2 and d3. In this case, d1, d2, d3 are real numbers. If it is equals to 0, then I will declare that as homogeneous equations. But okay, first we will discuss non-homogeneous equations. So whatever these three equations he has given, to declare whether it is consistent or inconsistent, we should express this in a matrix. So these three equations can be expressed in three matrices. First is A matrix. So in A matrix, what are the elements we will write? We will write the coefficients of x, y, z. Only we will write the coefficients of x, y, z. In a first row, we will write the coefficients of x, y, z of first equation, that is a1, b1, c1. Next, in the second row, we will take the coefficients of x, y, z of second equation, that is a2, b2, c2. Next is third row is coefficients of x, y, z of third row, that is a3, b3, c3. After this, I should write a matrix X, and in this X matrix, I should write the coefficients. There are three coefficients here, so I will write those coefficients in column. And next, again, I should take a matrix B, and in this matrix, I should write only the constants which are present in my right hand side of the equations. So what are those constants? D1, D2, D3 in a column. So student, whatever the three equations he has given, that we have expressed in three matrices. So if I see these three matrices, then I can write this as AX is equals to B. AX is equals to B. Because if I multiply these two matrices and I equate with B, I will get these three equations. After this, I will multiply A inverse here. Multiply A inverse on both sides. So what do I get? A power minus 1 into A. X is equals to A inverse into B. And student, in matrix we studied that A inverse into A is identity, because it is A power 0. That gives identity into X is equals to A inverse into B. So student, we know that identity into X is, it is X. Anything multiplied by identity is that element itself. Okay, here it is, X is equals to A power minus 1 means inverse of this matrix. And just now we discussed what is the formula to find inverse of a matrix. That is 1 divided by determinant A into adjoint A, B as it is. So student, this is a very, very important formula, and based on this formula we will check whether the equation, these equations, the three given equations whose variables are x, y, z, has solution or not. If it has solution, how many solutions, and then we will declare whether it is consistent or inconsistent. So everything depends on this formula. Now student, if suppose here this determinant, if this determinant is not equals to 0. So student, here there are many cases now, so we'll discuss one by one. Case 1. Student, in case 1, if this determinant is not equals to 0, if my determinant is not equal to 0, then this matrix X or the given equations has unique solution, because your denominator is not equals to 0. It has unique solution. Then equations has unique solution. Now student, the solution we can find by the method called matrix method. How can you find that solutions? By using matrix method. So student, in this concept, if the determinant is not equals to 0, then we can declare that the given equations has unique solution, means the value of x, y, z are unique. And how can we find those values? By the method of matrix method. Student, this is a last method of this determinant chapter. This we will discuss in our next video, because in my today's video my intention is to explain you about consistent and inconsistent. Okay. Now after this we will discuss the different cases related to this formula. So I will write the formula again here. 1 divided by determinant A into adjoint A into B. Student, in our first case, we studied that if this determinant A is not equals to 0, then we will get equations are unique solution. The value of x, y, z are unique. So student, we declared that the equations has solution, whether it is one solution or any number of solutions, but it is one solution if it is not equal to 0. Then what kind of equations those are? It is called as consistent equations. The equations are consistent. So in case 1, the equations are consistent because determinant is not equals to 0. Now let us go to the next cases. Case 2. Student, in this case, if suppose our determinant A is equals to 0, our determinant A is equals to 0, then we should find adjoint A into B. We must find this adjoint A into B before we declare anything. So student, here B is not equal to 0 and adjoint A we should find. After that we should multiply these two things. So student, again here 2 more cases will come. So under this, the first point is if adjoint A into B is not equal to 0. If adjoint A into B is not equal to 0, means numerator I have something but my denominator part is 0. So student, then the system of equations are inconsistent. Then the system of equations are inconsistent. Why it is inconsistent? Because it doesn't have any solution. Why it doesn't have any solution? Because denominator part is 0. Because the equations does not have any solution. The equation does not have any solution because the denominator part is 0 and numerator part is not equals to 0. Next point with the same case, the second case, if adjoint A into B is equals to 0, means if the numerator part is also equals to 0, then the system of equations are the system of equations have infinite solution. Infinite solutions. So how can we say that it has infinite number of solution? Infinite solution means it has infinite number of solutions. How can we say that it is infinite number of solutions? Because here numerator part is 0 and denominator part is 0, because determinant is 0 already here, we consider. Now student, 0 by 0 is what? We know that 0 by 0 is indeterminate. What do you mean by indeterminate? Indeterminate means it has many solution. This 0 by 0 in our first PUC we studied in limits concept that 0 by 0 means it is indeterminate. And why do we call it is indeterminate? Because it gives infinite number of solutions. So student, here it is infinite solutions. The moment we said it has infinite number of solutions or it has solution, then we can declare that the given equations are consistent. Then the equations are consistent. The equations are consistent because it has solutions, and the truth is infinite solutions. So as I said, the definition of consistent, that we need as solutions, whether it is one solution or more solution. If solutions exist, then it is declared that consistent. If there is no solution, then the system of equations we can call it as inconsistent. So student, I hope you people understood about the consistent and inconsistent when it is non-homogeneous equations. Now students, now we'll go to the homogeneous equations. Student, here in any equations, if the right hand side part, that means our constant part, is 0, then those equations are called as homogeneous equations. Example, a1x plus b1y plus c1z is equals to 0, a2x plus b2y plus c2z is equals to 0, a2x plus b2y plus c2z, it is 3, a3x, b3y, c3z is equals to 0. So you can check these three equations. Here, in all these three equations, the right hand side part, that is our constant part, is 0. Then student, these kind of equations are declared as homogeneous equations. So student, if I express these three equations in a 3 matrix, then I can express like this: A equals A1, B1, C1, A2, B2, C2, A3, B3, C3. Now x is equals to x, y, z, b equals to, always it is 0, 0, 0. Our b is a 0 matrix here. Our b is a 0 matrix, that is null matrix, because all the elements are 0 here. So student, to declare the consistent and inconsistent of this, we should follow the same pattern. So directly I will come to the formula, that is ax is equals to b. With this I will get x is equals to a power minus 1 into b, that is x is equals to 1 divided by determinant a into adjoint a into b. So student, here just one case will come here, because student, here since b matrix is 0, so then this part is always 0. This part is always 0. The reason is because b is already a null matrix. So if you multiply any matrix to null matrix, obviously the answer is null only. So the remaining part is only determinant A. So student, in this case, in this formula with homogeneous equations, if our determinant A is equals to 0, then the equations has infinite solutions. Now student, here the equations has infinite solutions because numerator as well as denominator both are 0, as I just explained 0 by 0 concept. So since it has infinite solutions, then the equations are consistent. The equations are consistent. Then in another way, in another case, this is the first one. Second, if my determinant is not equal to 0, if my determinant is not equals to 0, then this numerator part is, anyhow it is 0, this numerator part is always 0 here. Adjoint A into B is always 0 here because B matrix is 0 matrix. 0 into anything is 0. So we should focus only on determinant A. Now student, here if determinant A is not equals to 0, then we will get unique solution, and the solution is what? 0 only. Then equations as unique solution, and student, the solution is 0 only. Unique solution, solution is 0. That is, the solution means here the values are 0. That I will write value is values. I will write values are the values in the sense the values of x, y, and z are only 0. So what happened to the equations here? The equations are still consistent because here solution exists. Equations are consistent. Equations are consistent here. Student, I hope you people understood the concepts of consistent and inconsistent, and it is purely based on this formula, whether it is consistent or inconsistent, whether it has unique solutions or infinite solutions or no solutions. Everything is depends on this formula, and this formula is very easy to find because B is already given. If it is non-homogeneous equations, B is not equals to 0. If it is homogeneous equations, then B is always 0. And we know how to find adjoint of a matrix, and we know how to find determinant. Then if you know how to find everything, then we can easily compare and you can easily declare the final results. Okay students, let us have some examples about consistent and inconsistent of equations. So the first one is check the consistency of the equations. Check the consistency of the equations x plus 2y is equals to 2 and 2x plus 3y is equals to 3. Student, here the question is check the consistency of the equations x plus 2y is equals to 2 and 2x plus 3y is equals to 3. So student, here he has given two equations with two variables. So first we will express these two equations into three matrices, and after that we will solve this and we will see whether we are getting unique solutions or no solutions or infinite solutions. Based on that we can declare the consistency of these two equations. So solution. So first matrix A. The matrix A is coefficients of x, y, z of first equation. 1, 2, okay. Next, coefficients of x, y, z of second equation. That is 2, 3. Matrix X, variables. There are only two variables, x and y. So it is x and y. B matrix. B matrix is 2, 3. Two constants. Okay. After this, first thing is determinant. Our determinant. Determinant A equals to 1, 2, 2, 3. What is the determinant here? 1 into 3, it's 3, minus 2 into 2, it's 4. So 3 minus 4 is minus 1. So student, this minus 1 is not equals to 0. Okay. After this, let me take the adjoint of this directly using shortcut method, since it is 2 cross 2. What is the adjoint of this? 3, 1, minus 2, minus 2. Student, let us substitute this in the formula. The formula is x is equals to 1 divided by determinant A into adjoint A into B. So student, you know determinant is not equals to 0 here. So first let me find adjoint A into B. So x is equals to 1 divided by minus 1. Adjoint is 1, 2, 2, 3. Then B is 2, 3. So 1 divided by minus 1 is minus 1. Minus 1. 2 matrix multiplication. You know that first row, first column it is 1 into 2. It's 2. 2 into 3. It's 6. Plus 6. Now next second row, first column, 2 into 2 it is 4, plus 3 into 3 it is 9. So it is minus 1 into 8, 13. Student, it is not equals to 0. Means this x has unique solutions. So student, x is equals to minus 1 into 8 is minus 8. Minus 1 into 13 is minus 13. This is not equals to 0. So here adjoint A into B is not equal to 0. Determinant is not equal to 0. So this has unique solution. Therefore, the equations as unique solution. Since it has unique solution, then we can declare that the equations are consistent. Hence, the equations are consistent. Let us go to the next problem. Check the consistency of the equations x plus 2y is equals to 5 and 2x plus this is 3y 6y is equals to 8. So student, this time again he has given two equations and he is asking same thing. We should check the consistency of these two equations. The equations are x plus 3y equals to 5 and 2x plus 6y is equals to 8. So let us solve this. First, A matrix. What is A matrix here? 1, 3, first row, first equation, coefficients. Second row, second equation, coefficients. 2, 6. Okay. X is x and y, two variables. B is 5 and 8. Okay. First student, we should find determinant. Always first is determinant. Determinant is equals to 1, 3, 2, 6. This is equals to 1 into 6, it is 6, minus 2 into 3, it is 6. So 6 minus 6, it is 0. Okay, student, here the value of the determinant is 0. Now everything depends on adjoint A into B. Let me first write its adjoint A. What is adjoint A matrix? 6, 1. Interchange the principal diagonal elements. Then change the sign of other two elements. Minus 3, minus 2. This is the adjoint of the given matrix. Let me multiply this adjoint by this adjoint A into B, that is numerator part. So 6 minus 3 minus 2 1. Now B is 5 8. Yes student, determinant is 0, so I cannot directly substitute in the formula, because if I directly substitute in the formula I may get it is not defined. So first calculating both separately, then we will see what kind of conclusions we can give. So here again first row first column multiplication, 6 into 5 it's 30, minus 3 into 8 minus 24. The next second row first column, minus 2 into 5 it's minus 10, 1 into 8 it's plus 8. So how much it is? 30 minus 24, it's just 6, and minus 10 plus 8, it's minus 2. This is not equals to 0. So student, here that means in the formula determinant A into adjoint A into B. So student, here if I substitute in the formula, the denominator part is 0. My denominator part is 0. So that means the given system of equations does not have any solution, because determinant is 0 here. So I will substitute the value 1 divided by 0 into 6 minus 2. See, anything divided by 0 is infinity, not defined. Therefore, the system of equations does not have any solution. Does not have any solution means the given system of equations are inconsistent. Hence, they are inconsistent. They are inconsistent because it doesn't. These two equations doesn't have any solution. So, student, I hope you people understood this. If you have any doubt in today's concepts, you can put your doubt in comment box. Now, student, to help other students, it's your responsibility to share our videos. And if you are new to our channel, don't forget to subscribe. Thank you, students.